Um, okay. Today I want to discuss two two things that were still kind of openish in the last face-to-face meeting, and that was the discussion of using MPI count as timestamps. And for that, I don't have the text ready to discuss yet, because it's more of a question to the people on the call. In the terms chapter, there is at 2.5.8, we introduce counts, and there it's basically discussed what width the count can have, and basically in the upper bound of whatever MPI int or offset is, whatever is the larger of the two, will also be count. And what's more interesting is, well, let's just read that in as described above. MPI defines types to address locations within memory and other types to address locations within files. In addition, some MPI procedures use count arguments that represent a number of MPI data types on which to operate. At times, one needs a single type that can be used to address locations within either memory or files, as well as express count values. And that type is MPI count in C and integer kind MPI count kind in Fortran. So the question now there is, do we need to explicitly change the text in here to explicitly name MPIT timestamps as count variables? Because as I read the text here, as well as express count values, and count being in italics, it looks to me as if if this references arguments whose names are count, like the count for incens, for example. So, and as the arguments in the MPIT events section are not named count, that wouldn't apply here. So, should we add a specific text here in the terms chapter already to introduce the usage of MPI count as the timestamps?
It might help, Marc-Andre, if we talk about what we think a timestamp is before we ask if we need to change the definition of count. And sorry about the geese. Go back on mute.
Well, that is true. That is another part which is tricky on this, because the term timestamp is not defined yet in the standard. But that actually then the question is, I think it's hard to introduce it here because it basically it's about counts and not about timestamps. So we would have to introduce it someplace else. So from what you say,
right,
that would actually indicate that we should actually have its own kind in there. And not use
I think too, I mean, the way that I would interpret it is that, you know, if we have a timestamp, then we would have to I think if we're thinking about timestamps as being a count of some time unit since some period or some time in the past, then it intuitively makes sense that a count is a natural thing to use, even if we haven't specifically said how we're defining the timestamps yet.
Okay, so I like the wording that you had. Could you
I think I said something like if we define timestamp or as a count of some time unit, some number of time units since some point in the past. Then I think it is natural to use count as a type for that.
Yeah, that's good.
Here, Christoph from HLS.
Yes.
I'm not familiar with this topic at all, but I was just remembering that MPI time has at least some timing information in MPI, so maybe cross-checking if there's already something about how they define it here.
Yes. The thing is that is in the environmental chapter, time and synchronization. Mm-hmm. And in principle, Catherine's wording of since some time in the past is similar to what's written there. And yes, I totally agree that we should reuse the wording. But I think for this, it's already the chapter 8 where this appears, 8.6, is too late for or we need to forward reference. But then again, I think rather forward reference to the MPIT chapter where actually MPI count is used, because 8.6 uses the notion of timestamps or time. No, actually, it doesn't use the term timestamp. It just says it returns the number of seconds since some time in the past. We have it here. MPI returns floating point number of seconds representing elapsed wall clock time since some time in the past. So we don't have the timestamp expression introduced there as well. But good for bringing that bringing that up.
Okay.
So
thanks.
Thank you. In summary, I would then go for some version of Catherine's sentence right after in Fortran, because actually this and the type in is MPI count in C. So it needs to go behind right after the express count values, and then kind of find a formulation that blends in well, and then the sentence can be concluded with, and that type is MPI count.
So I don't think we need to put any. I'm sorry if I was confusing. I don't personally think we need to put anything in this chapter to talk about timestamps, because I think the points they have in there are examples, right? It could be an offset, I'm sorry, I'm trying to read this on my phone. So or a number of data types. And then later, when we define timestamp and call it a count, I think as long as we give that intuitive, we'll give a more specific definition in that chapter, but it's a count of something, then it just makes sense for it to be a count.
I totally agree. That is why the notion of using MPI count there came up in the first place. The problem I see, or potentially see, is that this being just a list of examples, it also is an exhaustive list of examples. So the question is whether people feel not naming. So basically, it says MPI count is basically something that can be either some location in memory or in a file, or something where the argument name is count. Whether if we just silently use it later, even though we explain it at that point, as motivated accordingly, we make this list here to be non-exhaustive. And the question is whether people would like this list to stay exhaustive, then we would have to add something, or whether it's okay to not mention it, whatever.
I personally think it's okay not to mention it, but
okay.
I don't know what others think. I think the reason it came up in discussion before was because we didn't define what we meant by timestamp, and it wasn't clear that it naturally fit into a count variable.
Okay. All right. Okay. So then, okay, we'll leave it there. So then we move back to things that I changed. What I now did I think I didn't push this yet to the branch, to the PR. But so what I did is in the reading, we had all the source information also placed in reading event metadata at the very end of this section, where we had, let's go there, jump there quickly. We had the MPI T event get timestamp as the first function to get metadata, and the MPI T event get source as the other one, and then everything came after that. And what I now did is I moved the function of MPI T source get num and MPI T source get info up to the section where event sources are actually discussed. So I think that's the more natural place. And then again, the second point of discussion would be that in the discussion of what MPI count is, how wide MPI count is, there's something that came up, and that the width of what MPI count actually is in a specific implementation. Because we were discussing that 64-bit integers would be fine for any timestamp for counting nanoseconds, because then we would have like enough time to measure things for I don't know, was it 100 years or something? But it was large time span, and but the wording in the terms chapter says, well, MPI count is not necessarily 64-bit or required to be 64-bit. It just needs to be large enough to actually hold an MPI-A int as well as file offset. So now if we think of not a current HPC system, but some embedded system that says, well, I want to run on 32-bit, and I also don't care about files larger than 2 gigabytes or 4, depending on signed, unsigned. Then also the file offset, the MPI offset could also be 32-bit, and then the count would be 32-bit, and then that might make the timestamp, or that would make the timestamp 32-bit, and we would be in danger of overflow in realistic measurement time. So the idea was to return also what I now call MPI max ticks, which is the maximum count of ticks reported by the source before overflow occurs. so that a tool can actually see what's the largest timestamp that I will ever get out of MPIT get timestamp or MPIT source get timestamp call, so I can identify when something overflowed. And also in that discussion came the idea to also return an optional info object handle. So initially the idea was to return the max ticks as part of an info key, but we still have the problem that at the moment we're not allowed to use info keys before MPI init and after finalize, and therefore if the max ticks was just an info key, then currently a tool wouldn't have the possibility to identify overflow or to estimate overflow when the source information is actually obtained before MPI init. And that, to my mind, is a standard use case for MPIT. You do MPIT init, then set up your measurement infrastructure, and then do MPI init. So you would actually query the sources mostly before MPI init. Of course, you could, if you do it in an MPI init wrapper, you could do MPIT init, do some information, do some initialization, do the PMPI init, and then get source the source info afterwards. I don't know how people feel about that. Should the max ticks be part of the function arguments, the explicit function arguments, or should it rather be an info key that is then in the current version only returned after MPI init and before MPI final?
That's a tough one. For future proofing, I think I would vote for the info key because it seems like we, over time, have thought of more things that we want to add to get info, which is kind of weird that we'd be returning an info key, but.
I didn't get the last part. I think it was swallowed by the system.
I think I vote for the using info keys to retrieve this kind of information, only for future proofing the API.
Yeah. Okay. All right. So,
I don't know other opinions.
Any other opinion? All right. Okay. So then I would go for removing the max text again and just adding the info key, which was not part of the reading, and then we'll add text that there is a specific info key that can be returned that contains the information of the overflow. All right. Okay, that's that. And that was actually what I was currently preparing. I think I have to stop sharing for a second and start sharing again. No, that's not the one. All right. Everyone see a editor window, Vim?
I don't.
Oh no. Okay. Yeah.
No.
Yeah, actually, so let's go for the full screen thingy again. There. Now.
Yes.
Yes.
Okay. So the what I'm currently working on there is actually what Jeff pointed out in the meeting, where we have the wording. So we now have MPIT event get info, MPIT source get info, and I think we have one more. There might be one more, but we have at least those two output variables where optional info arguments are returned, and I think the other two are input arguments. So, but because it's output arguments, you can't put MPI info null in there, but we would actually have to provide null as the argument. So, or let's say, the point that, let's go. Do you now see the document again, the standard, or don't you see anything?
See your editor window.
Still the editor window. So okay. So let's see if I can just share the full screen and then entire screen, and then it's easier for me to switch. Is better?
The same.
So
yeah, no, we are seeing the document.
The document. Great. Okay. So we have the event type query function, where we have the info object here, and the info object actually is a pointer to an info object. Yeah, and usually where you provide MPI info null, it's not the info. It's actually an info key, where it's an info key and not a pointer to an info key argument. So Jeff's argument was the user can't provide MPI info null here, but has to provide the actual null pointer for the calls to ignore this. And I just wanted to bring this up in the discussion to verify that everyone has the same understanding there. Because, like, thinking about it, I think I agree, because the problem is if you provide MPI info null, and it's not a the MPI info null is not the null pointer itself in a specific implementation, but some other memory location that identifies MPI info null, then it's difficult for the implementation to actually identify whether it should do something with the info argument or not. I don't know how people would think, because I think it's we don't have other examples in the framework where an info null can be passed. The other example, and that's where I copy pasted the text that I was preparing. That is from the info, and it's from the communicator. So let's see, get info. Yeah, 278 was. Get info. So the wording there is MPI get info returns a new info object containing the hints of the communicator associated with com. So, and the question now is, can we actually reuse this wording, or do we have to? So the problem is you can call MPIT source get info, which gets the naming issue that we have MPIT calls that are called with a name get info that return more than just an info object is a different matter. It's just legacy, something we've broken in the past. But now we're allowed to call a call before MPI init that potentially returns an info object. Info objects are not allowed to be handled in any way or created in any way before MPI init through the user. The question is then I can, if I have, let's go this way again. Let's just use this editor window as source code editor program. So we would have something like this. So I would initialize this like this, and then do MPIT source get info with some arguments at some point do info like this. Would that be valid, or would we rather want this? Or would we rather want this? So, so we have these.
So what was Jeff's argument about why we would have to use null instead of info null? I didn't quite understand why the MPI implementation wouldn't be able to recognize MPI info null.
So the thing is, we currently, MPI info null can be used where the info is an in argument. Yeah.
Mm-hmm. But this is an out.
When it's an out argument, it kind of just says, well, it returns a new info object. Yeah, it will. And if there are no keys, it will be empty. And the question that we have to deal with is, what will it return if it's before MPI init and there is no such thing as info object?
MPI info null.
Yes. So the thing is, option 3 and option 1 are not the same, because one is a variable that is set to MPI info null, and the other one, so it's kind of like a pointer to MPI info null, and the other one is MPI info null.
Yeah,
right?
I see what you mean.
Yeah, so it's like if we think MPI info null to be the null pointer, then option 1 would be a pointer, a valid pointer set to null, right? So you would get a non-null address, but it would point to null. And
yeah. Is MPI info null a constant?
it is a constant, I think. Oh, no, well, the constant is a predefined handle. So that's info null. There it is. Yeah. So here it's we see it's an in object or in direction. So
So I'm sorry, I didn't see that on my phone screen. So it is a constant.
So it's basically it's in the constant or predefined handle index. Yeah, whatever that means. I think MPI doesn't specify whether something is like a constant int or whether it's a special object that MPI recognizes as some form of a specific handle, a predefined handle.
So, speaking for OpenMPI, this is an object.
Right.
Yeah, exactly. Exactly.
Could be a constant.
So, so the question is whether MPI could yeah. So in principle, that means that option 3 is not valid.
Well, could we just say something that if you call this routine before MPI init, no matter what you put in for that argument, it will be ignored?
We could, yes, we could. I think that is a new option that I didn't want to explicitly name, but yeah, that's an option to explicitly discuss the behavior of those calls before MPI init and after after finalize. Yeah, that so. How does everyone feel about that? Saying explicitly that that the info argument of those calls are ignored before MPI init. That would mean once we
once we figure out how to handle info before in it, then we just delete that, I guess.
Yeah. Once we have that ticket dealt with, then we would have to change that specific text again. So I think the initial idea was to not needing to change that specific text, but just at some point say, well, info keys are allowed now, and everything else is implied. How do people think about that?
It just seems like a whole lot of work for something that might happen. I don't know, and it doesn't seem like it's that hard if you do fix the info problem before MPI, and then after finalize, it's just to delete a line. Everybody will nod their heads, I think.
Yeah. Okay. All right. Yeah. Well then,
Christoph, I just had maybe there's a fourth option. So for some of the calls, we had something like MPI status ignore, for example. So maybe one would think about something like MPI info ignore here.
Oh yeah, that is actually.
So because with this null, I have always a problem to see this in the code, whatever.
Yeah. Yeah. Oh yeah, I like that because it actually is the same, deals with the same problem that statuses have. You would provide a pointer to something, just say, well, ignore this altogether, and it's the same here. And then the wording could just be well, in situations where or like before init and after finalize, user can provide MPI info ignore to indicate that this should not be returned. And it can also, or it basically at any point, you don't need to tie that to init and finalize. Actually, you can just, whenever you don't care about an info object, you can actually provide that.
Yeah. However, then in the meaning to ignore it for, say, file system IO, whatever, there you use normally MPI info null, so in this case. So.
Yeah, but there it is an in argument, right?
Yeah.
So that's the thing. Is you want to their MPI info null is the short path, so you don't have to allocate an MPI info object to pass into, or like at the variable to pass that into the call, and so this here would be the equivalent for you don't care for that you don't actually want to allocate a variable that could hold the returned value. So kind of just like the statuses.
Does info ignore already exist?
No, I don't think so.
Okay, so then that would give us a dependency problem on ticket, but if we can work that out.
Oh, so you would say we would get rid of the info ignore again at some point. So yeah, I would think we could we just say
Oh, no, I don't think there's anything wrong with MPI info ignore. All I mean is before we would be able to get our events ticket passed, we would have to get the info ignore ticket passed, right?
Why can't info ignore be part of the events ticket?
I don't think it's clean, but maybe I'm wrong because it would involve a different chapter, and it talks about a different possible behavior for all the info calls. And so, I mean, we would have to go back and re-examine what that means for them.
Okay. Yeah. So I was just thinking about they're explicitly saying, well, you can provide MPI info, ignore it. Of course, you're right. One would have to discuss this in the MPI info chapter. Yeah. So that makes things still a little bit more difficult.
Yeah, like I said, I like it. I just think we just have to really think through how that will work out, especially since we're kind of on a time crunch for,
Yeah. So the question that I was thinking, if the user, we could still have options one and two work in with the current semantics of MPI info objects, right? Because I didn't call MPI info create, I just created a variable on the stack that is assigned MPI info null, and the implementation shouldn't have any issue with figuring out that it won't actually return anything or modify this info object if it's MPI info, if it's before MPI init. So we just have to find the wording for it to tell the user, don't expect this argument that you put in to actually change when you're before MPI init and after final. Right? Then the implementation will just automatically ignore this. Okay. Any more thoughts or input on this issue with like favorites from the people? All right. Okay. So then I think I'm through with what I wanted to discuss today, because I think all the other changes were minor issues and don't really touch semantics of the interface, but just clarifies things and fixes some wording that wasn't there or wasn't clear enough in the last reading.
Thanks, Marc-Andre.
Thank you, Marc-Andre.
All right. Thank you for joining. And yeah, we probably then now have to have like a 10-minute break before we continue, right?
Yeah,
Probably.
I was looking. I don't see Puri, so I don't think we can start early. So I suppose people will have 10 minutes to do whatever, and hopefully Puri will arrive and we'll shift gears. So it is the top of the hour, but Rolf just sent an email to the list saying that he was on his way with a new PDF. So I assume he's presenting something and will be here shortly. So I guess we'll give him another minute or two to come in. So, still don't see Rolf. I sent him an email and he didn't respond, so I guess we can probably go ahead and call it. Sorry for having to sit around for an extra 20 minutes, folks.
I don't know. I saw a mail here at least that he was
Yeah, he
preparing.
sent an email 10 minutes ago that he was coming, but now it's 10 minutes after we were supposed to start, so I don't
I
want
will
to
see
keep
if I
wasting
can
people's
find
time.
him. Yeah. Give me 2
Okay.
minutes.
Okay.
So Rolf is on the way. So should be here in a minute.
All right, we'll give him another minute.
I'm very sorry that I'm late. So
So
the
you
next one
have the ball, so you can go ahead and start presenting.
yes, my apologize that I'm so late. The first what I must do is to share my PDF. Yes, and where's my PDF? Acrobat. Is it doing something? Now it should start. Can you still hear me? Oh.
Yep, we can hear you.
Yes. Okay. It's doing something.
Got a black screen.
I have a black window. I did say LaTeX and yes. Can you see my PDF?
Yes.
Yes. Okay. I'm sorry I'm not able to store it. Therefore, at the moment I have only this online version. We are going to page 11. So, red are the total changes. Blue are the new changes since Chattanooga. We said that we want to add here the routine. We said that we want to use control instead of, what was it before? Content. and we said that we want to have parameters instead of resources, such as buffers. But the major changes are that I changed the definition of non-blocking. This means now I have, can you see this? That I highlight complete procedure?
Yes.
Good. I have done the definition of a complete procedure and an incomplete procedure. That's in principle what we always are using. An incomplete procedure is that it has still some parameters in use. Complete, then all parameters can be reused after the call. That's in principle exactly the definitions that we had for blocking and non-blocking. And now, for the definition of blocking, we combine that it's, no, I started non-blocking. For non-blocking, I combine that it is incomplete. That was the definition since MPI 1, and additionally says it's local. And with this trick, we do not have the problem that we have non-blocking routines that block. With this trick, non-blocking routines always are really not blocking. And of course, blocking is the contrary of non-blocking. Therefore, here it's incomplete and local. Therefore, it's here complete or non-local. And here I have done an advice to users. Note that for communication-related procedures, in most cases, incomplete procedures are local and complete procedures are non-local. That's an old advice to users. And exceptions are noted where such procedures are defined. In many cases, in the procedure name, an additional prefix letter I as an abbreviation of the words incomplete and immediate marks non-blocking procedures. Examples for in/complete and non/local procedures are, and then non-blocking procedures that are these incomplete and local, I send, I receive, put and get. Blocking procedures complete, the case is complete and non-local. That's in principle send, receive, broadcast. But the rare cases are the incomplete and non-local. That's, for example, mprobe. Mprobe is incomplete because it produces a message handle. And it's non-local because it waits until the message is there. Or the MPI broadcast init, it's a collective routine. It's really waiting. It's really allowed to wait until all processes have called this routine. But it's incomplete because it uses a persistent request handle. And the other cases are the blocking routines that are local. For example, bsend or iprobe. They are local. And in our working group discussions, we said it would be good to have these examples here. Otherwise, people cannot imagine what are these 4 groups. But with these 4 example lines, I expect these definitions are well readable.
So, Rolf, just as a comment, do we really believe that MPI mprobe is incomplete? Is an incomplete procedure? It produces a message, yes, but
a message handle.
That message, right? You can use that message handle. It is complete in that it has produced the message handle. The operation.
You must. That's the same as a request handle. You can also say MPI I receive is complete because it produces a request handle, and then you must use wait. This means a message handle has the same quality as a request handle.
So in which case, complete is not then referring to the function; it's referring to the operation that function is progressing or associated with, right? The operation, certainly receiving, is not complete once you've done iReceive. It's only complete once you've done the wait or the test returns flag. The flag is true, fine. But the procedure is complete in that it has done what it said it's going to do. It's produced the message handle in mProbe's case and the request handle in iReceive's case. I think that's quite difficult. That's quite difficult to argue that the procedure is not complete, is incomplete.
Yeah, especially with your new definition of incomplete procedure. The mProbe, all the parameters of the parameters you're allowed to use, because mProbe doesn't have buffers or anything.
Yes, I understand.
So I think what is meant by complete and incomplete is whether the operation that is represented by the function or associated with the function is complete or incomplete.
Yes, you are right. Yes, I remove mProbe. mProbe is the wrong example. Yes.
But I think it then exposes a potential problem with what you've described as complete and incomplete procedures. I think that the procedures, a complete procedure, isn't maybe the right phrase. It's a procedure that completes an operation. You've got to get operation in there somewhere, because an incomplete procedure implies that the work of that procedure has not finished yet. But what it actually means is that the work of the operation that is associated with that function isn't complete yet.
Is not complete.
That's a different thing. It's subtly different, but it is different.
Okay, this means we should modify this definition of incomplete procedure.
Mm-hmm.
Okay. An MPI procedure is incomplete if it returns before the user is allowed to reuse parameters such as buffers, or before the operation it is part of is complete. Would this bit be better?
I'm starting to get to the heart of the matter. Yes, I think so, but I'm not entirely sure that's completely fixed it. No pun intended.
Okay, but I would also say it's better to enlarge this incomplete procedure, because for me it's important because
So do we in general, a general question to everybody, do we think that incomplete in all cases returns a request which you then later have to complete? Is that the semantic that we're trying to get across here? Is that an incomplete thing, whatever it is represented by a request handle which you then later have to do test or wait on, which will then complete it? Are there any instances where we want to describe something as being incomplete, where a request handle is not provided by the thing that is incomplete? How would you then complete such a thing?
In ARM, the standard RMA functions don't have request handles, and they're it's like implicitly non-blocking, so incomplete.
Yeah, the input. MPI get.
Yeah.
They are incomplete.
And there are versions that do have requests, but they are also incomplete. Yeah. Both put and output are incomplete.
Yeah. I would say it returns before the user is allowed to reuse parameters such as buffers specified in the call, or it returns a request handle that must be completed in a later stage.
I think it's potentially even simpler than that, in that the defining feature is that the operation that is represented by that function hasn't completed yet, which then has a consequence of the user isn't allowed to use buffers. Right?
Yes, but we have a problem. Then we define here at the beginning incomplete procedure by using operation, and later on we start to define operation, because operation is coming here.
So that's defining properties of MPI operations. It's not defining the operation.
Yes. Yes, you are right. You are right. The operation. Yes, an operation is a set of more of. Yes, you are right. Yeah.
So
that's here.
That definition, we can then say that.
We can. Yes.
Yeah. So I think an incomplete procedure is one where the operation associated with hasn't completed yet. It returns before the operation that it's associated with is complete, which has the consequence that the user probably can't use the parameters, buffers, etc. Right. So the defining property is that the operation hasn't completed. The consequence is that you can't use the parameters. And in the blocking case, it is precisely because the operation has finished that you are now permitted to use the parameters again. Right. The parameter usage is a consequence of the property we're trying to get across.
Yeah, I agree. I like it better that way.
Okay. This means I would combine it. Procedure is incomplete if it returns before the user is allowed to reuse parameters such as buffers specified in the call, or that the operation is associated with.
I'm suggesting we change the word so that the defining feature comes first, which is incomplete. Procedure is incomplete if the operation it is associated with is incomplete, which has a consequence of. The second part of the sentence is the consequence of that is the way that affects the user is, that they can't use buffers and parameters and stuff.
Yes.
That's the consequence of the property, that rather than it's not the first thing in the sentence. The second
Yes, you are right. Yes, you are right. Yeah. And then, can you write me? Can you send me an email, or can you send an email to the working group with exactly this definition of incomplete, together with this additional sentence about the parameters, the reuse about the parameters, this second sentence, and then also how to define then complete as contrary.
Yes, I could certainly draft something. After this meeting, but yes.
Yeah.
So I think that if we settle on that, then I think that mprobe then is incomplete.
Then mprobe, yes. Because by this definition, mprobe is incomplete. Yes. Yeah.
Yes.
Okay.
Which resolves that conflict.
Yeah. Yes. Okay. Yes, okay, then we have.
I would then say, actually, before we move on, Rolf, I think that then means that iProbe is also incomplete. Which would make sense because it's got I in it.
No, because iProbe is completely finished. It doesn't return. It does return information, but there's any freedom what you are doing now.
So, I guess that it pivots then on is iProbe associated with any operation at all? If the answer is no, then it can't be incomplete by definition because there is no operation for it to be associated.
No, I would say, whoops, where do we get music? For me, iProbe is a complete blocking procedure and operation, and at the same time, it's local.
So I would certainly agree with local.
And local.
I would certainly agree with local. I think that what I'm questioning is if iProbe told you that there was a message, so it's basically a way of testing for a message. If it's that there is such a message, then is that associated with the operation that it's found? If it is, then it's an incomplete, because the operation is certainly incomplete because it hasn't completed that operation, right? If it doesn't find one, if it says no, there is no such operation that matches your parameters, then it's not associated with an operation. Therefore, it can't be complete or incomplete. There's no operation for it to be associated with, so the property doesn't make sense, right? So I think.
Then think about a multi-threaded application. 10 threads are doing an iProbe. 10 threads get back the exactly same status, but only one thread will receive this message.
Okay, so one thread will complete the operation, but the other 9 won't. But that's not really the point, is it? I think all were told that there was such an operation. All 10 of them, at the point they were told, must realise that it's not complete because they've only probed for it. They've not actually completed the operation, right? They've not received, and so it cannot be complete. And so, yes, there's a race condition between those threads. It's probably a rogue program that you've just described, but that's also, I think, the point where iProbe returns, the thread that called it potentially knows there is an operation that is incomplete, and potentially knows there is no such operation that matches the parameters, right? In either of those two situations, it's either valid to ask, is it complete or incomplete, because there's no operation for that property to be associated with, or you know for certain that the operation it is associated with is incomplete. So in neither of those situations is it complete.
Yes, I understand what you mean. I resolved in the annex. I resolved this in the way that I I differentiate between an MPI receive after a positive iProbe and an MPI receive.
I think your audio is breaking up, Rolf.
What is? My audio has a problem. Can you hear me? Hi?
Okay.
Hello?
Yes,
I can hear Rolf fine. So,
yes. We have a little bit problems with Dan.
Okay, Dan, just me then.
That's yes. Sometimes your audio is also a little bit slow. It means to listen to you is sometimes a little bit complicated because of your audio. Have you your camera on? I would recommend you switch it off.
No, I have no video.
Okay, no video. Good. Good. As I said again, in the annex, I differentiate between a receive without a probe and a receive after a probe or a positive iProbe. Because then the receive is a local function, and otherwise it's a non-local function. That's the way I resolve the problem. That there is some special behavior.
So I think that probably conflates two things that are orthogonal. Local and what we used to call blocking and non-blocking are not the same property and don't actually relate to each other. They are orthogonal to each other. Whether a thing is local or non-local doesn't actually affect it can also be blocking or non-blocking, and therefore it can be incomplete or complete. I think there is, by our definition, we actually now have a third category, which is an operation that is not associated with an operation. So we have now, it is associated with an operation which is complete, and it is associated with an operation which is incomplete, and there is also a third category of it's not associated with an operation. So I think that iProbe could be in either of those two final categories. It could be either not associated with an operation because it returned no, there is no such operation, doesn't match your parameters, or it could be associated with an operation, and in that latter case, it is certainly incomplete because you've only probed for it, you've not done a receive. Even if you subsequently later do a receive, yes, sure.
Okay.
Operations that are currently incomplete at some later point. That's great. So I think that iProbe is a really tricky exception. I think putting it into complete examples here is most definitely wrong, but whether it should go in incomplete every time or not is another matter.
Then if we would say that in the case of an iProbe, of a positive iProbe or a normal probe, that the probe is part of an operation together with the receive, that we have the probe-receive pair as one operation, then we have the problem that it does not fit to our initialization, starting, completion, and freeing stage. Because in principle, all this, you provide the message platform with the MPI receive, you are doing the starting and the completion and the freeing all with the MPI receive. You would not say that something of that is part of the probe.
So I think in that case, what you're arguing is that iProbe is never associated with an operation, and it is therefore never complete or incomplete. Applying the words complete and incomplete, or indeed blocking and non-blocking in our previous terminology, does not make sense with iProbe because it's not associated with an operation. It is simply giving information about operations that may or may not be exist. If you wish to then do something that is associated with the operation you now know of the existence of, great, by all means do a receive.
Okay, this means this means we have. Okay, yes, I understand. We have, in principle, we have routines that are not associated with an operation, but they are communicating routines.
So iProbe is not a communicating routine, it's a local routine. I would put it in the same category as WTime and memAlloc and things like that. It's not associated with an operation. It provides some information which might tell you something about an operation, but it isn't associated itself with an operation. It is the same category as WTime or alloc mem or free mem or one of those, a data type routine.
Yes.
None of those are associated with an operation.
Yes. Yeah. Such routines can be collective, like duplicate a communicator, MPI comdub.
So comdupe is associated with an operation because you can. Comdupe is associated with an operation. The operation is creating a communicator, right? And it's a complete procedure because the operation is complete when comdupe comes back. And there is an incomplete version of it, iDupe, which is incomplete because the operation isn't complete because you have to wait for the request. You could, devise a persistent version of it and initialize a comdupe, and then you have a persistent version which is also incomplete because the operation is incomplete. There's an operation involved there. That's not the same category at all.
Yes, an mProbe is together with mReceive. Yes. This means iProbe is a very special case.
Yes. It is actually closer to being an MPI-T function, which gives you information about some internal
which
states
function?
in MPI. Sorry?
To which call?
To an MPI-T function, a tools function. You know, MPI-T,
tools
CVAR,
function, okay.
It's telling you something about the state of the matching list. It should probably actually be in the tools
Yeah.
part of the interface. And it never will be, but it's more akin to that type of function. None of the tools are going to be complete or incomplete because there's no operation associated with it.
Okay. Then this means we would remove it here, the iProbe. Okay?
Yes.
And
so I suspect that means that argument means that there is a third category, and we should probably be explicit about that in this text. We should probably say that some procedures are not associated with an operation and are therefore neither complete nor incomplete, or something similar.
yes, that we add.
Yep,
that we add here, exactly here before the end of the advice, we should add such a sentence.
Yes.
That would be helpful. And that's now MPI iProbe.
Yes, but we could also put in things like MPI alloc mem and MPI data type commit.
Yes, but these are the data type commit is a local routine.
Yes, but it's also
it's
not
like com-rank
because there's no operation.
Yeah.
Yes, we can apply local and non-local to pretty much every function because it's a property that can, I think, be applied to all of them. But
yeah,
it's orthogonal to the blocking, non-blocking, which is incomplete, complete.
Yeah. This means that there are routines that, okay, that for them we are not doing these categories.
Yeah, I think we should just put a sentence in saying that some procedures are not associated with an operation and therefore are neither complete nor incomplete. Or possibly we should just define the
because because we define complete and incomplete through operation, and those functions that are not part of an operation. Okay.
Mm-hmm. Yeah. So we can either define that they are neither complete nor incomplete by our definitions, because there is no associated operation, or we can simply say that we will call them complete because we've chosen that. It seems to be the most logical thing to do. If there's no operation, then how can you wait for the operation to finish? How can you complete the operation if there isn't one? So, you've done all that you need to do to complete any associated operations, so they're complete. Basically, the answer is null.
Mm. Can you do a proposal for exactly these three things? The new definition of complete, of incomplete, and exactly this. What we should do with iProbe.
Yes.
Whether there is female, male, and diverse.
I may need to write a note to myself. There's more of these things than just one or two. Let's do definition for complete.
Seid ihr schon durch?
Nee, ich habe gerade, es waren so wie nur Leute, die haben es dann allein gemacht, die wollten nicht. Also ich bin ja gar nicht, habe die Führung gar nicht gemacht.
Es sind nur 8 Leute im Rechnerraum mit.
Ja, genau.
Achso, okay. Oh, das verblüfft jetzt bei 30 Teilnehmern.
Ich bin drüber gesaust, das kann der
Okay.
noch gesagt, ich soll doch irgendwie letzte Sekunde, dann bin ich extra rüber. Dann habe ich gesagt, nee, braucht jetzt doch nicht 10 so wenig. Und dann,
Okay, gut.
ja, okay.
Good. Then, are you writing the text now, or what are you doing?
Yeah, yes, I'm trying to draw something now, and I was going to then stop if you then said something else that I needed to listen to.
Okay, no. No, what, are you writing it or not?
Yes.
You're writing it. Okay, then we wait.
Ah, okay. I'll write back then.
Okay. Must I switch off my sharing of the PDF that you can share your editor? Then?
You could do, yes. Indeed, I could type in a more public way if you wished me to.
This means I'm switching off and you switching your... Okay, good. What must I do? It happens automatically. Good. You did.
Yes, I have the power apparently.
Yeah.
So I suspect that's not big enough for you to see. So let me just zoom in a fraction.
Okay.
That'll do.
Yeah. See it.
So can you see that? Read it.
Yes.
Perfect.
Yes.
Perfect.
Thank you.
Good.
Definition for complete procedure. Complete procedure.
Is not or should not. Yeah. So should that be is not permitted or may not be permitted? I think we should probably shall not be permitted.
I would have say more may not be permitted.
Yeah, I think. Do we want to be more definite about that and say the user is not allowed, is not permitted to reuse the resources, or is it that in some cases they are? And how are they going to know whether they can or not?
Yes, I would say may not be permitted to reuse some parameters, for example, buffers.
If you put may not, I'm not sure that you need the some parameter.
Yeah.
So that's why I
Yeah,
prefer
yes,
may not
yes,
instead of
may
shall,
not.
because shall not be permitted to reuse
Parameters,
parameters.
yes.
It might just say that you are not allowed to reuse any parameters, which is not what is meant. I think may not is better here, but I'm not an English expert, so.
So I think there's also a slight problem with the circular definition here in the complete procedure depends on completing operation. So as long as this happens after we've defined what completing an operation actually means, and I think we define that in terms of there's a function which completes it. So hopefully that's a complete function or a complete procedure, because there's a circular definition. An operation is completed with a complete procedure. A complete procedure is, completes an operation. I think that there's some issue there.
Okay. Okay.
Those are the two alternatives I see. I think the first version, are neither complete nor for incomplete is a cop-out. I would think that I would come down the side of it must. If we're going to define it as one of those things, then we have to define it as complete. I think it makes no sense to me to define MPI alloc as being incomplete, because how are we supposed to complete it? All right, so it has to either be defined to be complete or defined in such a way as the property complete or incomplete doesn't apply to it, which of course is nonsense, because the complete, of course, applies to it. So I don't really want to make the situation. The first sentence here suggests that the thing isn't complete. And of course it is, it's allocated memory. So, so I suspect that the right thing to do is this second sentence. I'm not really sure how to join these two bits of sentences together. But we define to be complete, or we put this bit in between here.
Yeah, I think this is better, but I don't know exactly how for example, the alloc name is defined. If it's defined to be blocking or something like that. It's just that I don't remember if all procedures are either blocking or non-blocking right now in the MPI. It's by default they are blocking, except when they are said to be non-blocking or persistent. I mean, do we consider that allocment is blocking or not, or should we consider something like that? Because if we should, then we must define this to be complete, to be blocking. With the new definition of blocking and non-blocking.
Yeah, I mean, I would just that things like allocmen are blocking functions by the previous definition of blocking, because you can use the resources that are specified in the call. I mean, it might be that the address returned is 0 and that actually it hasn't allocated memory, but you can read that memory address and you can make a decision about what's happened. It's not like you're being given back a pointer that isn't filled in yet and might be filled in at some later point. It's not a future it's an actual address that you can use. The resources have been released back for the user to do something with. It's a blocking function. So I think that this is correct. I think we should just be arguing about the wording of it.
Yeah, okay.
So I'm favouring this last iteration of it.
For which which would you use? The first, second, or third?
The third. The one
Yeah.
I highlighted, MPI procedures that are not associated with an MPI operation are complete by definition.
Yes. Yes, I would also prefer this, because then
So I hear no
all,
objections.
yes, because then all routines are blocking or non-blocking at the end.
Yes, by the old definitions.
Yeah.
Yes, they are either all complete.
And that fits better to our MPI 1.
Yeah. Okay, so I'm going to delete those bits.
Mm-hmm. Yeah. Okay. Good.
Okay.
And yes. Okay, then we may go back to the PDF, I would say. No, we nearly have no time. But we never looked at this exception text. We should, if we have additional 5 minutes, we should do it. What must I do to share again?
So I can do stop sharing. So have you written down what I've written down, Rolf? Or do you want me to read that to you?
You send it to me, okay? What?
Okay.
What I want to go is also, because we never looked at those lines, when I remember correctly, like 41. For those routines like bsend, for all these exceptions, for all these routines, going back to 11, for all these routines here, for the strange routines, I wrote some small sections. We discussed it in the working group. This means we had this text already in Barcelona, or we produced it in Barcelona and discussed it later on in the working group. But when I remember correctly, then we had no time to read this text in Chattanooga. Therefore, I want to mention it here, that we have it. For example, for buffered send, according to the definitions in section 2.4, MPI bsend is a blocking procedure because the user can reuse all resources given as arguments, including the message data buffer. It is also a local procedure because it returns immediately without depending on the execution of any MPI procedure in any other MPI process. Advice to users: this is one of the exceptions in which a blocking procedure is local. Okay, again with a new definition of complete and incomplete, saying something about the operation. We have to change this text a little bit. But in principle, I would say we keep these exceptions, telling the user here are the exceptions. Another exception is 52. Here I added for the prefix, I added the incomplete. And we have the next exception, about 59 or so.
Before you move on there, Rolf, at page you send.
What do you say?
What page it was. So on a previous page that you just moved away from, it was the definition of the MPI iSend function, and it has a sentence after the binding, which says that this is a standard mode non-blocking send. And that.
Then stop. I cannot understand you. Who is typing? Then are you typing? Somebody is typing with a microphone. Dan, can you say it again, please? I understand nothing. Dan?
I think we've lost Dan's audio, but also I think we've probably gone beyond what we're going to accomplish in this call anyway, so perhaps Rolf, you and Dan should talk offline and can circulate a draft afterward.
Yeah.
All right, so I think that's the end for today's call. We have another one next week. Obviously, we had another spammer in the middle of the call this week, so Jeff Squires and I have been trying to figure out how we're going to disperse the registration information for next week. Keep an eye on your emails. It'll probably come out soon.
Okay.
Thank
you all. Thank you and goodbye.
Okay, thank you. Goodbye.